Hmm. All right, here we are testing sound. Yeah, do. Testing the other sound is not at all here. Beautiful. Okay, 3, 2, 1. Hello, good morning. How's everyone doing? Good afternoon, good evening, good mid evening if you're in the Fiji Islands. I don't even know what I'm saying at this point. I may have had way too much coffee this morning before starting. How's everyone doing? Very happy to be here as usual. Are we live? We are live. Yes. All right. So, um, oh yeah, the boilerplate. Hi, my name is Jose Luis. I run this thing called Parametric Cam. We do computational design live streams. We record tutorials live in the company of beautiful people from the Parametric Cam community that chime in with their opinions and their requests, etc., etc. and and then we edit them and we post them live on our YouTube channel. That's pretty much what we do. If you want to know more, you can follow us on social media. We're pretty active on Instagram. And if you want to also be part of the conversation, we have a Discord server where we have conversations and people post questions and troubleshooting, whatever. The Discord server, there's a link in the description of this video. And we also have a Google Calendar. The link is in the description of this video so that you can know when we go live. We also post things on Instagram when that happens. Nicolas Jarudi, ICB. I don't know that we know each other. Welcome to the channel. Saeed, how are you doing? It's been a long time. So, all right, we got a lot of work to do today. So let's get ready for that. So what are we doing today? As you probably already know, we are wrapping up. Well, I thought we were wrapping it up, but the other day, well, we are wrapping up the playlist that we've been working on called Advanced Development in Grasshopper. And we have finished a big chunk that was prototyping our components in C# scripting within Grasshopper. And hey, Michael, how you doing? And we're kind of done with that, and we're going to transition into a new section, the last section of that playlist, which is going to be about native development of native plugins in Grasshopper. So what we're going to do is everything that we have learned for C# scripting, we're going to see how that applies to native development, so that instead of sharing C# script components, we share the bundle, compile, nice components that are part of a plugin that have their icons that you can put on foot for Rhino, that you can download with the packet manager, and all that stuff. That's going to take us a few videos because in the previous live stream, we sat down and we wrote the curriculum of this part of the series together with the help of people from the community in the chat. I was actually really happy to do that in company. And so we have a few videos to do. So I'm actually thinking very seriously to start doing double streams and in February. So to do like morning and afternoon streams so that we can just, kind of get done with it. I'm thinking about that. All right. So maybe we do, maybe we don't, because I don't really know. I'm also really busy in my real life, in the real world, with my job/jobs. I have a lot of stuff going on, so I'm not sure if I can spare like a full day every week this month, because I have a lot of other projects that really requires my attention. But anyway, I'll do whatever we can. So what are we doing today? Today, I would like to develop. We're going to go back real quick to the section where we were doing C# scripting, because reviewing the playlist, I realized that we recorded this one video where we explained how to do custom previews, and that was super interesting. And we did like a couple of small examples, but I think that is a very important topic. So I would actually like to record a video that is dedicated just to just an example of like other things that you can do with custom previews. All right. So we're going to do that today. And if we have time left, because I really need to like practice and figure out the things before we actually record the videos. If we have time left, we will start with the native development part. So we will start talking about basic concepts around native plugin development, the difference between native and C# scripting, what is a Grasshopper plugin, what are those files that you download and you install, what does that mean? And Nicholas, what do you mean by amazing? You mean the double streaming? Is that what you're saying? I think that would be amazing too. I just don't know if I can afford it because I have a really busy month. Still the beginning of the semester, still a lot of things that I need to deliver. It's kind of a lot. By the way, how's your arm, Nicholas? Is it healing? Is it healing well? All right. So let's get busy. Ooh, let me check. I don't know. Okay, so we were Dramatic Camp. I need to check on which side I need to be recording. So we're live. How beautiful is that? So Grasshopper 11. So wait, where is the playlist? The playlist is Advanced Development in Grasshopper. So the video that we're going to record right now would be right after rendering custom previews. And I guess for some reason I was on the left-hand side, which I don't like, because for the rest of the videos I was doing the right side, but I think I'm here because like for one video I switched and then I forgot to go back. So I'm gonna stay on the left side for this video so that I continue here, I think. But then for the next section, can you please remind me to switch to the right side of the screen? Yes. Let's do that. All right, Drillon, I'm not sure we've met before. Welcome to the channel. So, what are we doing today? As I said, today we're going to do we're going to do more examples of custom preview. Oh, I don't need my face here. We're going to do more examples of custom previews. And for that, I'm going to open Grasshopper. But first, I need to prototype what we're going to do as an exercise. So what are we going to do? Let me pull the file that we had been working through. So that would be this one, document components. OCD alert. Jairudi, what's going on? Where is the alert coming from? Excuse me. Where is the alert coming from? I'm going to internalize the data here. Yeah, I think that's my OCD now triggering for sure. Dynamic simulation components. I don't know. If I load this, do those go? No, they don't. Anyway, so utility components, document components. I guess here I would like to do something like preview components, but oh, okay, I see. Well, thank you for being here, Drillon. I really like doing this in the company of other people. So here we're going to add a new folder that's going to be E9, E.9. What am I doing here? E.9 preview. Oh boy. I've had a lot of coffee this morning. This is not going to go well. Preview components. Okay, and then here, and I'm going to turn off Dropbox because it's kind of sucking up a lot of resources. Preview components. How's everyone doing? I have not been watching any of the Winter Olympics. Nicholas, But my phone keeps like telling me that there's like all these things going on with athletes that are choosing different countries and like referees doing weird stuff. I guess that's how media works now. They just highlight everything that goes wrong, that you don't get like the nice, good news of anything. It's kind of sad. Anyway, let's stop being cranky and let's get working. So, for preview, for custom previews, what are we going to do? We're going to do 4 examples. Those are going to be cool. This is going to take some time to do, but it's fine. I think they're good, very good examples. We're going to do 4 examples. One's going to be a vector display, so the one we just did in the previous video, where I'm just going to add the possibility of customizing the color. So we're going to do that. I also want to learn how Grasshopper handles colors, which is a slightly different than standard C#, I believe. So we're going to take a look at that. And we're going to do a component. So you know how you can do this? You can have a curve and then you can say, can I do curvature analysis? And no, wait. Can I do the curvature graph? And up. How do you see the curvature graph? Curvature, extract, curvature graph. How do you get that nice diagram with the sticky, the lines that are perpendicular in the curvature graph? Let me Google that. Rhino curvature graph. Yes, exactly. How do we get this? What was the command? Curvature. Curvature. Set a point on curve for curvative measure. No, but I want... Can someone help me here? I want the full diagram. Curvature analysis. Tangent. Curvature graph. Analyze surface tool. Go to analyze and find it there. Analyze. There's no analyze as such. Go up to menu, analyze. Analyze curvature graph on. Okay, but is it because is it the scale that is just not? The scale is just really low. Oh, okay. Well, that sucks. But how can I not make it bigger? That's really not great. Huh. And the density, I guess, is just how often we get this, right? Which I don't really know what it means, but density and display scale. But this is kind of lame. Ah, okay. Yeah, what was going on with that? That was very strange. This is what I want. So, okay, so we're going to do this, basically. I think. Because these curves are going to give us some trouble, but I would like to mimic that in Grasshopper. Okay, with the custom preview. Scale is super sensitive, I can see, yeah, totally. You're right, Joe. Thank you for that. So we're going to do one of these. I would also like to do, so you know how you can have a surface. So for example, I don't know, 4-point surface, right? And then let me take the points, and then I'm just going to add here. Okay, and then for this curvature analysis, all right, so for this, let me do auto range. So for this, you can see how we can color code a surface with different values for the curvature. So I would like to do something like this in Grasshopper as well. And last but not least, I would like to take a mesh, and I would like a mesh that is made out of quads, and I would like to measure the planarity of each one of those quads, which is also going to take some code. This is going to take some time to do, but I think it should be quite fun, actually, and very interesting from a coding standpoint. So we're going to try that. So I would like to do a component where, given a mesh as an input, we go through all the faces, we test the planarity of that face, and then we color code that quad with a particular color based on planarity. Okay, so that's what we're going to do today. And because I don't know how to do any of this, what we're going to do is we're going to try doing it now. We're going to do the examples. I'm going to figure out what it needs to be done in order to explain them, and then we will record the actual tutorial. My hair is kind of crazy today. I need to get a haircut. Yeah, it's getting out of control. I'm getting a haircut. So next time we meet, you're gonna see some like sleek, like, you know. Anyway, I have really overdone coffee this morning. All right, so first of all, let me go back to the first thing I want to do is a vector pre-visualization, just like we did in the previous video, but for this one, I want to be able to customize the color. That's very important. So let me see. So for custom display, what we did was this. We had this object here, all right? So I'm going to copy this and I'm going to paste it over here. I'm going to copy this whole stuff here. I'm going to copy this. I'm going to change, I'm going to paste it. I forget. Here, exactly. I'm going to paste it here. I'm going to drop a point here, and then that point is going to be here, and I'm going to internalize it, for example. All right, and this is going to be, this doesn't need to be so big, and this is just going to be something like that. Okay, and this, oops. And I am going to do this and this and this. All right, and then we have the vector. So we have anchor and vector. So, but I also want color. Also, by the way, am I doing long names or what am I doing here for the other components? I guess we can stick to longer names, I guess. Or for this one, we can do, okay. And so let's do anchor, oops, no, what have I done? That's not what I want. Vector, vector, okay, vector, and then color. All right, and then here I would need to change that this, we want anchor, here we want vector. All right, so that's it. Now I need to bring in here, this is what I need to explore. I want to bring in here a color. So I only have system drawing colors, which is the native C# implementation for a color. Let's see how that works. So if I have my color parameter here, and I plug in a color, so for example, color from RGB, whatever, and this is giving me some kind of black here. So if I plug this in here, do I get a color? So let me print c.toString. and we run this code, and the panel is going to, it gives me a color. All right. So it looks like, yeah, we do have some kind of color representation here. All right, so what that means then is that I just need to pass in here I need to create a persistent variable also that is going to be color, and then that I need to use to pass into the renderer function. So color is going to be this whatever is given here, and then argument display arrow. So here the color is just going to be this whatever color comes in from the outside. All right. So that's going to be that, and then therefore I can now just drop here a component that goes to 0 from 0 to 255. That component, and so that would be the red, the green, and the blue, and then we can just okay. So that's going to be that one. But also something that I would like to do is I would like to have a Boolean variable. No, I would like to display the length at the tip. And so instead of text here on the screen, I would like to display the text on the at the very tip. And that would be cool because then if you have a lot of vectors, you can see which one is the longest, kind of. So instead of just one here. And also because if you display many vectors, the text is not going to overwrite. So in order to do that, I would say length, and that's going to be an input, and this is going to be a Boolean variable, and then a toggle here, and then the toggle is going to be a Boolean variable, Boolean display text, all right, and then display length, display length sounds much better, is going to be equal to whatever the user gives me. And then here, if display length, then I will do all this stuff, okay? So right now, you see on, you can just see it here, on and off, on and off. But I want to do it here in 3D. So I think there is something, point location, draw 2D text. So I forget args, display dot, and let's see what we got. So in draw 3D text. Okay, so let's see what do we need in here. So for this one, what do I need? I need string text. So that's going to be, that's going to be vector length here, or just the length probably. I guess just the length, because otherwise it's going to get very busy. What else? System drawing color, text, the plane that we need to use, the height, the font face. Well, that's a lot. That's a lot of stuff that we need to add there. Is there a simpler override? Let me double check. So I'm going to go to developer tools, Rhino Common, draw 3D text, method, the text and the color, text, the color and the plane, text, color and the point 3D with an adjusted origin, the color, the plane. Let's work with this one to start. Let's see how this would work. So text, color, and just the location. Text, color, and then the location. What do I want for the location? The location, I want the tip of the vector. But for that, I will need to know the location. So point 3D, P is going to be equal to, so here I'm going to say P is going to be equal to A. And then here I would like to say A plus, at this point, the arrow is not doing any work here anymore. All right, so I'm going to say replace everything, anchor, vector 3D, vector, and then we have color, and we have display length, whatever. And then here, so I'm going to do anchor. Again, I'm doing this exercise just because I want to write the example and then we will record the tutorial. So here, vector, something is not working. It's giving me an error here. Yes, so here I would have anchor plus vector. Okay, and then this I'm going to turn off. Okay, the name arrow. Oh yeah, because arrow I need to create now a line object that is going to be called arrow, which is going to be equal to a line, a new line between A and A plus B, right? Sorry, anchor. Anchor plus vector. Oh boy, what is going on? The context arrow. Oh yeah, I guess. Fine, let's keep the element here. Arrow, okay, and then arrow will be created here. Arrow is going to be a new line between A and V. Okay, so we got that. 101, we got an error here. Arguments displayed raw text. Text to the color cannot convert string to what? It's not taking the right anchor plus vector. Okay, well let's start simpler here. So let's do this one. Can I convert from string to Rhino display text 3D? Text 3D text. Interesting. What is a text 3D object? Encloses the following bold. Oh, I see. Okay, so we need to do new text 3D and then this thing. Boy, that's... And text 3D is from Rhino display text 3D. Oh boy. So we need to... This is getting more complicated than I thought. Using Rhino display. Boy, okay. Finally, okay. And okay, so the text is showing up here. All right, that's not cool. All right, okay. And then the arrow is not showing up, which is also not cool. Why is the arrow not showing up? Arrow bounding box. Well, oh, did I delete the arrow? I think I deleted the arrow. Oh boy. Args dot display dot arrow draw arrow line is arrow and system color drawing is color. Yes, I deleted it. That's so nice of me. The line was A to B. Yeah, it should be A to A plus B. It could be A for A plus B, but it turns out that line has an overload. You see, you can have an overload that is between a point between 2 points, but there's another overload that is between a point and a vector. So because C# picks up already that V is a vector, it already does that. So we don't need A plus V. Okay, so that's here, and then the location, we need to add the location. The location would be arrow plus vector. So, and we got an error. Oh yes, so anchor plus vector. And then the text would be there, but then the plane is actually not very nice. The plane, and calculating the plane for this to show up is kind of not interesting. Arcs display. Let's see if I can draw to the text. Active annotation. Curvature graph. Oh, there's curvature graph already? Draw a typical Rhino curvature graph. Oh, okay, so we don't need to do this manually. That's kind of nice. Draw direction arrow. Draw dotted line. Extrusion wires. Gradient hatch. Gradient mesh. What is gradient mesh? Mesh, blah, blah, blah. Okay. Draw line arrow. No clipping. Lines, marker, mesh, shaded vertices. Object, particles, pattern, point, line, stereo, frame buffer, surface, draw text. And what is the difference between draw 2D text, 3D text, and just text? Let me see. So what we need to do is we need to go to Grasshopper preview arguments, and that is going to be in the Grasshopper SDK. Grasshopper preview arguments class. Okay, preview arguments, preview objects, preview wires, preview arguments. Exactly. Oh, an interface, but okay. So let's see if we got draw text. Nothing. And what about here? Draw text. Oh, this is Grasshopper 2. This is not the Grasshopper. This one. What about draw text? Display pipeline draw text, text entity and color. And there's nothing, there's no documentation. Sounds great. Well, let's see. If we find an easy solution, we will do it. But if it's too complicated and we need to calculate the planes and whatever, blah, 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 this is just not gonna work. So Nicholas, we could code it ourselves, but I just don't want to spend too much time doing that because I want the video to be focusing on drawing things and drawing previews. So if it's going to be like a super complicated algorithm, I think it defeats the purpose. So okay, arguments, display, draw text, draw text, and then text entity. What is a text entity? Seriously. What is Rhino geometry text entity? And okay. All right. Text entity, draw text. let's say text entity. Text is going to be equal to new text entity, and we're going to do this, and now we're going to say new text entity. Up. Entity. And text.text is going to be equal to hello, whatever. And here we're just going to draw text, and then the color is going to be black. Let's just start from here, from this, and see if this works. Annotations, text space is obsolete. Use rich text or plain text. Oh boy. It is, oh, a robot. Okay. All right. How do we do 3D text that shows up on the screen and is always oriented towards the screen? Should we do like a quick C# Grasshopper 3D text screen oriented? How to display text? Explorable, text entity, text tag, 3D, Grasshopper display, how to in the space, there's oriented 3D text. The 3D text maybe partially inside of the geometry so you get visual. Do you need to be sort of I need to appear? I have attached a file with one draws the text at a fixed size, the other adjusts force perspective. Oh, thank you, David. David to the rescue. So let's see how that works. It's always time to learn new stuff, folks, right? All right. So you see, this is what I want. I want like a world-oriented one. Plane, arguments, viewport, get camera frame. Plane origin, double pixels unit, get world to screen scale, pixels per unit. Whoa, okay, so you do the manual transformation. Okay, so plane, so we create a plane, we get the camera frame, the origin is whatever points. Pixels per unit. Get world to screen scale. Points, out pixels per unit. And where is this 25 coming from? Whoa, what is that 25 there? Let's explore it. So X is going to be a double number. We're going to plug in here 25. Then here we're going to do scale, and then scale equals X. And then here we substitute with scale. All right, so it still looks good. Well, I'm assuming, I see. Because the scale of the drawing depends on where we are and the zoom level. So he's just hard coding something that kind of looks okay for the screen resolution. Okay. Okay, do we want to get into this mess, or do we want to get into this mess for the example that we're going to do, or not? Get camera frame, out plane, plane origin. So it's taking the plane of the camera and it's moving that plane to basically the location point. and then pixels, get world to screen scale. Pixels per unit. Okay. And then it's just doing black, the plane, and the scale, and whatever the typeface. Okay. Yeah, why not? I mean, since it's an advanced since it's an advanced whatever, why not do it? Okay. So what we would do here is that we would say plane, we got a plane. We got a plane, the viewport plane is going to be equal to the anchor, pixels per unit. We want get world to screen scale. Anchor out pixels per unit. And then we want here the length to string. And then color black, the plane, and then scale, let's write here 25. And the name color does not exist because we need system drawing color. So I'm going to draw this here, and here, and here. Just drawing dot color. Okay. Ooh. All right, that was a lot. I also want to round this number to a bunch of decimals, and I want to actually set it here. So that would be, plane origin would be anchor plus 1.1 times the vector. So that it's like a little off exactly. You see? For example. Okay. I think we're going to do that. I'm going to go drink some water. I will be right back. I also need to change the batteries to this thing. I'll be right back. Give me a minute. Okay. I'm also thinking that I'm going to need to do some sketching for this playlist. I just brought my laptop to do like the drawing on the whiteboard kind of thingy. So, okay. If the microphone goes away, just let me know, okay? Because I have the batteries. Okay, so let's just wrap this up. So I'm going to just like do some, add some scale here. Like S is going to be the scale and it's going to be a number. And I'm going to write this number and the number is going to be, and we probably want to use the same color right? Okay, exactly. And I'm going to round this string. The string is len round is going to be equal to, how was this string format? And I forget, the format is something like 5D or something like that. I need to look this up. And the argument is length, and then length round is going to be equal to, what I want is here, length round. Just see this. Nope. The input string was not in a correct format. I knew how to do this, but I always forget. So C# string decimal rounding formatting. Convert it to decimal. Here. Okay, so here I like this one better. Yes. How to round this one is going to be something like this. And okay. All right. And the scale is going to be double scale, and then the scale is going to be equal to S. And then here we're going to have scale. All right, and so true, and then we have scale. All right, beautiful. And so that's nice. I like that. And we have everything that needs to be there. The clipping box is not taking into consideration these things. That's probably not a great thing, but whatever. And then if I do an example where I have a grid of points, and the point is somewhere here above, for example, and I bring this point in. I bring this point in and I set this point, and the size is something like, I don't know. The size is this, and I get all the points, and then I get vectors between 2 points, this vector being this one, this the other one, and then I just copy and paste this, and the vectors are these ones. Why do I only get the last one? What? That's not cool. List item access, what? Interesting, I only get one? Why do I only get one? Just one? Because this is rendering? Whoa, I did not, wait. So this component, that is so strange. This component, I thought it would render individual arrows for each one, but it turns out that it only does the last one, probably because the method, the draw viewport wires, is overriding itself, and it only draws the last one. Whoa, that's not cool. That is not cool. I would have liked. So what about, so when I do this, does this component ask for a list? No, it just does each for each point. So if I give it this anchor and all these vectors, that's what I want to get. But instead I only get the last one. Because I guess the viewport is just over the previous, the pre-visualization is overriding itself. Ah, well, that's not cool. Nope. Now, is that important for us? Do we need that for the examples? All right, it's taking way too long. Do we need that for the examples? Do we need to make one example where we take all the possible anchors, we take all the possible, we do data matching and blah, blah, blah? I think that's going to be a little too much. So unfortunately, I would have liked to show some kind of rainbow sort of, but it's just not going to work. Well, that's too bad. Maybe that's something that we can talk about as limitations. Vector display limitation. Every preview overrides the previous one. That kind of sucks. Okay, well, I guess it is what it is. At least, is this component done? Does it does it has everything that I think it should have? It does. Okay. Well, that sucks. Anyway. What if instead I just did the size? Here, literally just the scale. Because I don't want to get into... I think I kind of like this better. I don't like the... Yeah, I think I like this better, actually. I'm going to leave it like that. And so that we don't really need to care about the pixel units. Yeah, I don't think I want this. And this scale supposed to scale divided by pixels per unit. I don't like this. I also don't want to get into explaining that. It's a little too much. Okay. All right, so this was the first of the 4 that I want to do, which is vector display. Wow, all right. So that was a lot. Can you try to save the arrows in persistent data? I can. It's just that because it's just because I'm doing, Nicholas, because I'm doing item access. Basically, this component is just running. This component, if we have like, I don't know, 25 points, this component is running 25 times, one after the other. In order to draw all the arrows, I will need to switch this to tree axis and then get all the draw with a for loop, go through the whole tree and get all the elements and save them as a tree, whatever, which is it's very doable, but I think it would take a lot of time to do as an example, and it's taken away from the preview part, which is what I like, what I want to do. And then we can just iterate out of all of them, but that's something that I would just rather have the user do, at this point. Yeah, exactly. Yes, I know. We're talking about the same thing. Yeah, but I do not want to do that on the video because it's just too much. I would rather just say like, oh, you can do this on your own, and it's fine. And actually, I think that might be something that would get something that would get solved perhaps if we compile this natively. I'm not sure. Anyway, let's move on to the next thing, a component that takes a curve and visualizes the curvature graph. So let's do that. So I'm going to draw a curve here, right? And with a very kinky, all right, something like that. And I'm also going to give it some 3D quality to it. And I'm also going to, wait, I'm going to draw this in here. All right. So 3D curve. And this I'm going to hide. This I'm going to move over here. So I'm going to C# component. This is going to take a curve. But Nicholas, if you want to practice with that and share the example with us on Discord, more than happy. We can add it to the samples that will go with this tutorial. So here we have this, and then we're going to write here, we're going to add the overrides, and here we're going to add curve. All right, and then I'm going to specify that curve needs to be of the type curve. Where are you? And then here we say that lowercase curve equals the input. All right, so that's good. And then here we get curve dot get the bounding box in the clipping box, so that's good. And then draw viewport wires. So just for the sake of trying, arc dot display dot draw curve, and then we just pass in the curve, and for example system dot drawing dot color dot coral, for example, to just make sure that it works. Yep, here, and then we're going to hide this folk here, get bounding box, and then false, right? Exactly. And we don't need the output. This is coral. All right. Now, what we want to do is we want to draw the graph curvature, the curvature graph. So instead of this, what I want to do is, okay, arguments dot display dot draw curvature graph. And what do we need here? We need the curve, and we need a system drawing coral, which will become an input. I'm full encoding a game for Unity, so I'll look into if I get bored. Yeah, right. Good luck getting bored with that. Okay, we got the drawing here. Very small scale. And then let's just do black, because I think it's a lot of stuff. Black here. Oh, and I guess the curvature is too much. Okay, and this here, I'm actually going to just this one here, set one curve. All right. Okay, so the scale is very small. So let's say color, and let's add scale. Okay. And the color, we're also going to take some color from here. That color is going to be here, and then some slider from 0 to 1. For all the folks who might be joining late the stream, we are prototyping the examples that we're going to do for custom previews in the video that we're about to record as soon as we prototype the example. So I'm just like rambling and writing code and figuring out what things are before I actually formally record the tutorial. So right now we are creating a custom component that does some custom preview of the graph curvature of this curve. and I'm trying to figure out how to do that. So that's going to be curve. Here I want to do a variable called color. Oh my God, I'm really messy today. Color, and then double scale. Hey, Andres, how are you doing, sir? And then, all right, color is going to be equal to the input, and scale is going to be equal to the input. And then here, let's explore what other arguments do we have for the draw curvature graph. So we have curve and the color. Then we have curve, color, and hair scale, and hair density and sample density. Okay. Hair density and sample density. I'm not sure what those means. But I guess hair scale is what we have as a scale, which needs to be an integer. Density and sample density, I mean, we're just going to hair density and sample density. So we're just going to add them as inputs, okay? So this is going to be scale, and then this is going to be integer, hair density, and oops, sorry, that was totally wrong. And int sample density. I don't know what the difference is between those two, but this is going to be an integer. I always forget integer or integer. I always forget. So that's going to be 100. Here is never used and blah, blah, blah. I know, Andres, I've done a lot of coffee this morning. This is going to be hair density, which is going to be an integer, and hair density and sample density, which is also going to be an integer. And I'm going to plug those in here. I'm going to say that hair density is HD, and that sample density is equal to HD or SD. And then here, we're just going to display those black. And then here we're going to have scale. And at this point, scale is probably not the right word, hair scale. Hair scale, I probably want to change the name here. Yeah, hair scale. And I may change this here as well. Anyway, hair scale, then hair density, and then sample density. I'm going to run this, and it works well. Okay. All right. So am I seeing anything here? Hair density. Okay, let me hide this. Let me hide this. So right now, and why do I have black? I still haven't changed the color, right? So that would be color here. Second one. What do you mean, Nicholas? Scale. Do I need to make the scale bigger? Whoa. Whoa, okay. All right. Scale is here. Now hair density and sample density. Up. Looks like this is doing nothing. Absolutely nothing. So I don't know what that means, but we do have the curve and it's kind of nice. So, yep. Hair density. Beautiful. like it. It's kind of nice. But you're right, Nicholas. It would be a really cool exercise to actually draw this manually. A really interesting one as well. Which we're not going to do because that would need its own video. Absolutely. Scale is very sensitive. Yep, you're right, Joe. It's literally like it can go between 100 and 120. That's literally, it is very sensitive. Yep. And what's interesting is that if you say zero scale, what it does is it finds the points along the curve where there's a jump in the curvature, which is weird because I would assume that the curvature would be continuous. If I show the curve, what are the control points? So interesting. Can you see how the... Oh, interesting. Can you see how the curvature jumps more or less where the curve actually hits the control polygon? Interesting. Which is here and here, and that is because there's no continuity between the degree of... Wow, interesting. Oh, I see, Nicholas. So integer, right? Okay. Thank you, sir. All right. Interesting. Looks more like this is the arcs. It can be divided in... Well, because it's a degree 3 curve, it touches the contour polygon. But the curvature is not continuous because this is the first segment of curvature. This is the second segment of curvature. There is a jump in the curvature. They are tangent. That's why they're tangent. That's why this line coincides for both. Otherwise, it would be something like this would be one side and this would be the other side. But they're not the same value. The curvature changes. There's a jump. It would be interesting to know how the Rhino calculates curvature. It's the derivative, Joe. It mathematically is the derivative of the function that defines the curve at the point that you're calculating that curve. If you could possibly join my class, my Introduction to Computational Design class at the university, we talk a lot about those things. Okay, well, I think this is fine now. So now we need to move on into the real deal, which is taking a surface and color coding the surface based on curvature. So there's something here, right? Where is this? Here, surface curvature. So for example, let's say we take in a surface. Let's say I'm going to make a crazy surface. So I'm going to make a surface that is a line like this. Then I'm going to make another one. And then I'm going to make 4 more at regular intervals. All right, but this one, I'm going to rebuild it. And I'm going to put 10 points in it. And then I'm going to drag one of these here and another one here. And we're going to create a little bit of a kink. And then I'm going to loft this and this and this and this. And we get something like that. So actually, to make sure that we have something that is more planar, I would like to do this and this, and then loft this one, this one, this one, this one, this one, and this one, and make sure that so that this area here is sort of flat, kind of. Because I could do a tight one and I still get some curvature here. Straight sections. Oh, that doesn't, no, that's not what I want. Uniform, I don't know what uniform means. Let's do normal. Because at this point here, we're probably pretty planar. Okay, this is one surface. So I'm going to bring that surface in here. Yeah, I know its definition. It's a question of the actual implementation. That is right, but that's what Rhino sells as a value, you know? UV coordinate to evaluate. Evaluate the surface curvature at that, and we got the frame, the Gaussian curvature, and the mean curvature. I thought this gave us a graph. Hey, Kartik. Yes, you are a little late to the party, but it's absolutely fine. All right, so I don't get this. And let's assume we're going to reparameterize this thing, okay? And let's say that 0.5, 0.5 as a point, text to point. Okay, fine. Let me do this then, 0.5. Okay. Actually, let's do this 0, it's less confusing. So here we would have the frame. What is the frame? Where is the frame there? Oh, the frame is right there. Then the Gaussian curvature there is going to be whichever value, and the mean curvature is going to be this one. Okay. So how are we going to do this? I thought there was a component in Grasshopper that did this, but it looks like there isn't, which is great because then now we can contribute this ourselves. So what I want is something like this. Curvature analysis. I want something like this. I want to create a component that we give it the surface and it does something like this. Auto range. Max range. And we want the mean curvature, auto range. This is also pretty cool. So in order to do this, we're going to have to do the following. We're going to have to take the surface, subdivide the surface into an UV grid of points, create a mesh from that UV grid of points, and then color each one of the vertices with a particular color that represents this curvature, and render that on the screen, which it's kind of a lot. So, but that's why it's interesting as an example. So let's start with a simple example. Let's say that I'm going to take this surface, and what I want to do is I will render the surface as a mesh, first of all, to start with. So let's start simple with that one. So I'm going to take the mesh, all right? I'm going to take the surface, and first of all, I'm going to try to render a mesh out of that surface. Okay, so I'm going to take the surface, and then the surface is here, and then I'm going to add the overrides, and then I forget draw viewport meshes, so arguments is going to be display, and then draw. What was this? Draw gradient mesh. I don't know what a gradient mesh is, so I'm going to go for a regular mesh. Drawing grips, draw line, draw mark, draws the mesh faces as false color patches. The mesh must have vertex colors defined for this to work. Well, I don't know what that means. Draw mesh force, but that sounds interesting actually. False color patches. Mesh shaded, and then we add a material, draw mesh vertices, draws all the vertices in a given mesh. Draw mesh wires. Draws all the wires in a given mesh. Huh, okay. So, looks like, all right, so let's do real quick and dirty. Can we create a mesh directly from, can we create a mesh from a surface right away? UV mesh, is there something like UV mesh? Can we create a mesh class? Is there something to convert from a mesh? Not from a surface? No. Well, we're at intersect. That's not what I want. I want geometry. I want mesh class. Exactly. Is there something with a surface? Object type, clear surface data. Now, create from surface. Okay. And then there's also meshing parameters. Meshing parameters. Minimal. Yeah, so let's just do something real quick. So let's say that I store a surface here. Surface. And then here under S, I'm going to store S. All right. And now what I want to do is, first of all, I have the surface. I need to create a mesh with a surface that I can then draw here. So that will be mesh. It's going to be equal to this is a static function. So mesh create from surface. So mesh dot create from surface. And then I'm going to take surface, and then I could add parameters, but I will do that later on. Okay? I will do that later on. So now I have arguments dot display dot draw mesh with false colors, for example. And okay. And then for this, I would need surface dot get bounding box false. Okay, so is that working? This is working. Is this doing anything? Is this doing anything whatsoever? Nothing. What if I hide this? Do I get a preview? I am not getting a preview at all. All right, so clearly something is not going well here. Arguments, let's try something else. Argument, display, draw mesh, draw the vertices of the mesh. So that's going to be this one. Nope, not drawing the vertices. Arguments, display, draw mesh wires from this mesh. Also not, okay. Oh, that was why. Draw mesh vertices. That overload takes one argument. It doesn't? Okay, so what does it need? It needs the mesh and it needs the color. All right, so this color, let's do system.drawing.color.coral. And it's not happening. What if I move this here? Would that work? Do the vertices need to be in the viewport wires? Okay. Okay, what am I doing wrong? Is the surface is the mesh working actually? Let's see if we actually have something here. Maybe the mesh is just not properly being created, and I can't print anything because all right. So let's just do it in the main thing, just to debug here. So I'm going to print M2 string. Rhino geometry mesh. Okay, so print mesh vertices dot count, and it's gonna tell me that I need to do the strings. Seriously. Okay, 14,000. Okay, and if I were to output this mesh, it would actually look good, right? Yep, it's an actual legit mesh. Okay, so the mesh conversion looks like it's working. So it's not Rhino, it's me. Which kind of sucks. So, all right, so let's keep trying. So I have the mesh. Instead of drawing the vertices, let's see if I can display the wires. Arcs, display, draw mesh wires. And what do we need for that? We need the mesh, and then we need some color. Okay, so okay, all right, so that one works. That one works. We got the mesh. It's a little irregular. I don't like it, but we will eventually figure this out. We will write some own conversion. So why are the vertices just not showing up then? Let's see if there's some more overloads. Coral, draw the vertices for a particular pipeline. Draw mesh vertices. Draw mesh vertices. Rhino C#, draw mesh vertices. Conduit, draw shaded mesh. Demonstrates how to draw a shaded mesh using a display conduit. That's what we're doing here. Do I have to compute the normals? Examples. Command conduit, shaded mesh. You make a conduit. Yeah, but this is a little different. This is using a conduit, which is not exactly. Draw mesh shaded. You get the mesh, the bounding box. Material, blue, display shaded mesh. That's not exactly what I want. Draw mesh vertices. Let's see hot examples. Draw mesh vertices. And it's commented out. That's not a good sign. And there's only 2 matches. Okay. We're kind of screwed here. Okay. And it's already 11:20 and we still haven't even started recording all the way. Well, it is what it is. Draw mesh vertices. It's not working here. So, and this is also not working here, right? I wonder if like drawing points has its own override. And that's because it's not really a wire. It's more yeah, I wonder, that must have like its own thing. Okay, well, arguments, display, draw mesh, shaded. Let's try with this. And that's going to be the mesh. And then what else do we have? Face indices. So we're just going to create like a random material of sorts. I'm just going to Rhino, C#, draw mesh vertices. This was an example with a conduit. And the M material. Okay, so we're going to create a new display material. So display material, matte, new display material. And then we're just going to set the diffuse color to coral. Material diffuse is going to be equal to this thing here. And this is going to give me an error because something is missing. Here, actually, this should go all the way here. Here, display material is not because it probably needs to be imported. Okay, where is display material? Display material constructor, and it's part of the Rhino display. So using Rhino display, and okay, so now it's better. And then so we have a material, and then we're going to do arguments dot display draw mesh shaded, and the mesh and the material. If this doesn't work, we are in big trouble. Boom. Okay, fine. All right, this is working. Okay, so that's good. So what if, so the thing that I want is false colors, which is I want the mesh to be rendered with a different color depending on the vertex. For that, I need to add vertex colors to this mesh. So, okay. So then what are we going to do? So for mesh, I'm going to add vertex colors to this thing. So for int I equals 0, I is less than m dot vertices vertex colors. Oh, wait. So when we start a mesh, does it come with vertex colors already? So let me undo this and let me print vertex colors. I forget if we have to create them or override them. So there's 0 colors. Okay. And, all right, so we need to start those colors. So, and this we can probably comment out. Oops. We can probably comment out. We want the shaded mesh, but no. So we want for int I equals 0, I is less than mesh dot vertices dot count. So for each one of those, what we need to do is to go to the vertex colors, and we just need to add a new vertex color, which is going to be, for example, some weird brown, I think. Okay, and then arguments, display, draw mesh false colors, and the mesh. And come on, come on, come on. Boom! I think this is what we wanted. Let me say m dot vertices I dot z. It's not an integer. Integer, cannot convert from float to integer. So just cast it. Yes, you see it's redder here, and here it's not, it's a little more orange. What is the distance between this point and this point? It's 75. So I'm going to divide. Okay, so this is going to be the vertex divided by 75 and multiplied by 255, for example. What? Integer division warning. Exactly. Very good. -1 is not valid for green. Okay, fine. Let's just round down. Okay. Oh, hell. So I guess we just okay, whatever. It doesn't really matter. Okay, so that's good. All right, so we got that. What that means is that what we may want to do now is we have a way to render the mesh. So I'm going to, just for the sake of leaving this here, I'm going to leave this here for the example. I'm going to also I think at this point we're just going to create the mesh once, and I'm just going to create the mesh once, and then I'm going to do whatever it needs to be done, and then here, and then here, and then here, and then here, and then here. And 66, and well, we don't need this. I'm just gonna leave it here for debugging. And 92, where is 92? Here. Very good. And this one also needs to be replaced. Okay. Is never assigned to. Oh boy, you're right. So oh, okay, M, and now mesh, the global mesh is going to be equal to M. Okay. What happened? Oh, because we are, what? Why is this going away? Null reference exception? What the hell is going on there? An error occurred in the display pipeline. What? Why is this leaving us? Get bounding box. So maybe mesh, get bounding box. Why is this happening? Tell me. Tell me. Tell me. Why is this happening? Take the surface. I mean, really, we don't really need this anymore, honestly. $59 from S. Okay, geometry mesh. Why do you do this? What if I moved all of this somewhere here? Why am I doing this? Did I just really break it? I really broke it. Now it doesn't work at all. Oh no. Oh no. So it is something to do with the clipping. Oh, that sucks. I don't understand. I do not understand, and it's not cool. Oh boy. Okay. Well, we'll deal with that later. So, the whole point is that we need to. So now we need four. We need four. What do we need? We need to take the mesh, and for each one of the vertices, we need to compute the curvature, and we need to attach that to the mesh. Okay. And then we need to use that to color the mesh. That's going to be interesting. Am I getting myself into trouble? I am, right? Okay. So, how are we going to do that? Well, ideally, what we want is, first of all, we want to generate the mesh as a square grid from the surface. So that's the very first thing. Then the second thing we want to do, I'm going to write this as pseudocode. Generate grid mesh from surface. So that's the first thing we want to do. The second thing is, for each vertex, compute the curvature value. That's the second part. The third part is, for each curvature value, compute corresponding color. And then last, apply that color as vertex color. So that's what we want to do. All of these are actually pretty straightforward. It's just that it's going to be a little tedious. And I'm thinking whether if to organize this as a sequence of functions or one single function, and how data is stored. So can we add custom values? Append another mesh? No. Custom, there's no custom anything. Clear surface, remove surface parameters, curvature parameters, and surface statistics from the mesh. What is that? Clear surface data. What does that even mean? Suppose duplicate mesh, insert privacy equals evaluate mesh geometry. face normals, feels hope. Okay. Get the type. I wonder if doing it manually has value. Let's take a look at surface, at the mesh class, not the mesh clash, but the mesh class. Okay, so mesh, and then from surface with meshing parameters. What are meshing parameters? Close default, grid amplification, grid angle, grid for sampling quads. Grid max count. Okay, we will Rhino. Grid mesh from surface. Creating a mesh using a parallel grid. This is the okay VJ paneling tools. No, I don't want paneling tools. Add mesh. Panel grid quads. Evolute tools. No, that's not what I want to do. Paneling tools, mesh to surface. Not mesh to surface. What is this mesh to surface? Is this a plugin or something? What is this? Mesh to surface for Rhino. Oh, interesting. Reverse engineering plugin for Rhinos for converting 3D scans into meshes into CAD models. Huh, okay, that looks cool. All right, but that's not what I want. What's the difference in converting a mesh to a solid? Sub-D, mesh methods, I already got there. Well, I guess we're gonna have to do this manually. All right. Oof. Are we ready for this? Can you buckle yourselves up? Okay. I wonder is this gonna be too much? Is this example just too much? Because I really want to focus on the preview part. But if I'm going to have to spend half of the tutorial video just converting from a mesh to a surface, vice versa, it kind of defeats the purpose too. Is there an easier way of doing this than what I'm thinking, which is just sampling the surface for points, then reconstructing quad faces? Grid aspect ratio, minimal tolerance, refine grid, dispose. Tolerance, smooth, simple planes. Guesses where not planar areas are allowed to be meshed in a simplified manner. Relative tolerance, refining grid, whether or not a sampling grid can be refined when certain tolerances are not met. Quality render mesh. The mesh gets mesh creation parameter to create the render mesh when mesh quality is preferred over meshing speed. Smooth, minimal. Create minimal meshing parameters. Fast render mesh. Default analysis. Gets mesh creation parameters to create the default analysis mesh. That might be interesting because that one might be okay. Let's just try that. See if we can save ourselves a little bit of create from surface, and then we're going to do meshing parameters. dot default analysis mesh. Okay, we got that. It's gone. Are we outputting this? Can I see this? I cannot even see this? Weird. That's very weird. Why can I not see this? That is so strange. This is a really bad mesh analysis, whatever that's called. Okay, what else do we got? Default analysis mesh. Quality render mesh. Default course. Minimal. This is so strange that it's just leaving. Ah, well, this is nice. It does a square. It does quads. I wish I knew what are the parameters for this one. Can we find what are the parameters for this one? For minimal. For minimal. Oh, maybe we can just print them out to the console. So meshing parameters is going to be equal to this bulk here. So if I print, do I get a dump? Do I get an output here? Random geometry meshing parameters? Well, but I do get parameters dot all this stuff. Grid amplification, grid max count. Get to set the maximum number of grid quads in the initial. Maximum edge length. Refine grid. Simple planes. Maybe if I say grid max count has to be equal to 10, and then if I do grid minimum, it has to be equal to 10. And then I use this for meshing. Maybe I get a 10 by 10. Is that what I want? Parameters. And I run this. Okay. And then I get this surface that I bake. And I am not getting what I want. Wait, did I? I'm using parameters, right? Okay. And then grid minimum count. This is not getting me what I want to. Parameters dot grid amplification. Get or set the amplification. Get or set grid aspect ratio. Get or set the maximum allowed aspect ratio for sampling quads. That's going to be 1. Let's say I want square quads. Okay. And I'm going to bake this. That did have an impact. Interesting. Okay, now we're getting what I want to. Okay, and then we have all the vertices here. Can I actually render this? Is this going to flop on me as well? This one doesn't go, but the other one does. That sucks. I wonder if this is just... Weird. Weird. Let's say that I do parameters, length at maximum edge length equals 1, and then minimum edge length is also 1. Do I get anything? Oh, I get a pseudo squarish kind of thingy. Interesting. So I could, basically, because this is really doing nothing, I could just have a parameter, an input, which is going to be grid size, for example, and that's going to be a double. And I'm going to say that this is going to be this, and then this could be grid size, and this could be grid size. And now we have a sort of more controllable kind of mesh, which looks nice. And then what I want to do, I wonder why, is there something that I'm not doing well here? I'm gonna have to research this. Anyway, we do have the mesh now, so what we can do is something like to find the closest point for each vertex, compute the curvature value. So, for example, we can say for, sorry, I've been writing a lot of JavaScript lately. I is less than 0, I is less than m dot vertices dot count, and then I plus plus, and then what we do is 0.3d or 0.3f, I think, vertex is going to be equal to m dot vertices, correct? Yes. And then what I can do is I can say surface closest point, and that's going to be v, and then I'm going to get double u and v, closest point, out u, out v. And it cannot convert from 0.3f to 0.3d. Oh boy. Okay. So vertex 3f, and now I'm going to say, oh, and also, oh, I'm also mixing apples and oranges here. Yes, vertex 3f. Oh yeah, because I was mixing names, u and v. Okay, so that's there. So I get the closest point, and then I get the coordinates, and then I can do surface curvature at, and then I can find the curvature at u and v. Okay, and that's going to give me a value, the curvature, and then I'm going to print that value. I'm going to print that value, curvature. I'm going to print that to the console. Surface curvature to toe. Oh yeah, because it computes. Yes, you're right. Computes the whole thing. Surface curvature. It's the curvature, and then here from the curvature, I can actually get the Gaussian curvature, the mean curvature. So let me print, for example, the Gaussian one. Up. And you see we're printing like all these crazy values that are tiny. They're super small. Okay. All right. So once we do that, we can say double just an array curvatures, and that's going to be equal to new double and then m vertices count. All right, m vertices count, and we're just going to add the curvature here. Curvatures at position I equals curvature dot Gaussian. All right, so that's one. And then we can, let's output those curvatures just to get a sense of what's coming out of here. Yep. I am sorry that this live stream is becoming just a stream of coding, but I really need to practice these exercises before we teach them, right? So that's going to be this. That's going to be this, and then what else? So now we need to calculate the minimum and the maximum. Curvatures, double minimum curvature is going to be equal to double dot maximum value, and double max equals double dot minimum value. All right. And then here, I mean, since we're already looping through the whole thing, why not just double C is going to be equal to curvature Gaussian and then C. And now here, I'm just going to do the following. If C is greater than maximum, maximum equals C. If C is less than minimum, minimum is equals C. The idea here is that I want to be able to find which is the minimum and the maximum so that I can color code all these things based on their relative values. Okay, so that's one thing. And then I'm going to print minimum is minimum, and then maximum is maximum. And we got that minimum is this value and maximum is this other value here. All right, that's cool. Then this is getting really complex. Okay. What is next? What is next is the next thing we're going to do is compute the curvature. For each curvature value, compute the corresponding color. We're going to normalize the values. How about that? We're going to say normalize curvature. And it's going to be another array with the same thing. And then we're going to normalize this by saying for int I equals 0, I is less than curvatures, and actually probably this is a curvatures dot length. I mean, it's the same thing, it's just it kind of makes a little more sense. All right, so double difference is going to be max minus minimum. All right, so for each one, the value of the normalized curvature is going to be equal to the value of the curvatures is going to be equal to, all right, how did you normalize a value? I forget. You take the value, you subtract the minimum so that you get its absolute value. You divide that by the difference, and then after that you divide that by the difference. If you want to normalize from 0 to 1. Yeah. Correct? Yeah, right? All right. I'm totally now. Whoa! Caffeine, folks. It does stuff to your brain. Normalize curvature. Okay, so I'm going to do that, which means that all the numbers that are spitting out here should be somewhere in the range between 0 and 1, which they're clearly not. So, what are the bounds of this list here? They are what? 0 to 1? They are? Wait, I did it right? Oh yeah, because there's a 0 here. There's a 1 there. And all the other values are like kind of like eh. So these points have Gaussian curvature? That's very strange. Okay, well, so then I guess we can color now the vertices based on that. So let's iterate over all the vertices again. And let's say, for example, let's say that we're going to color code them red. Vertices count. So we're going to say m dot vertex color dot, we're going to add a new vertex color, and the red channel is going to be the vertex color. The red channel is going to be the normalized curvature times 255, and we're going to make sure that this is an integer, all of this, because yeah. And what? Oh wait, and now it's stable? And now it is stable. Oh, that's what was happening. Oh, because I am attaching the vertex colors in the main script. Oh, have you realized this, folks? Because I am attaching the vertex colors in the main script, the instance of the mesh that... Testing, testing. Thank you, Drillin. All right, have you seen what's going on here? Now, for some reason, this is stable. So the rendering preview is now stable for some reason. I don't know what happened. I guess we have to do the operations here in the mesh at the main code. I guess. All right. All right. Is this what I wanted? Wait, what have I done? Oh, no. No. Here. Is this what I wanted? I think it is what I wanted because it's very similar, but we're baking the mesh. Let me bake the mesh. Sorry. Let me bake the mesh by... Let me bake the mesh by actually outputting that mesh. Okay, so we're going to bake that. I'm going to bake this, and because it has vertex colors, it already shows up like this. Okay, and now, and I'm also going to undo this so that it's a little over the... Now I'm just going to hide this, and I'm going to do curvature analysis, and we're going to do Gaussian, and we can see that we get, we get these negative areas here. We get these negative areas here that are colored black. And we get these areas here that are whitish. If instead of red, we just did the full thing. Okay, so we did just grayscale. Yep. We did grayscale. That's not very optimal to repeat the same operation 3 times, but whatever. So if we now bake this, we get a grayscale representation of that. No, I want the mesh. We get a grayscale representation of that, which is, and this is not, sorry, this is not. So in the rendering, you can see that it's black here and it's white here, where the maximum curvature is. And anything in the middle is, which is also not a great thing, because for Gaussian curvature, you actually want to know where 0 is, because that's kind of important. But anyway, this is a good approximation. We got this figured out, more or less. More or less. So what is next then? The next thing would be, we're going to figure this out. We can input colors. I'll think about this in the next video, because I'm not going to record the actual video today. Visualizing the non-planarity. Visualizing the non-planarity. So that's going to be here. So I'm going to turn this off. I'm also going to turn this off. Shaded, whatever. We have this here. And I'm going to actually save this somewhere. Save as... okay. We're going to save this here. And I'm going to now use this with all the meshing that I've done. But this one, we want to calculate the planarity. So we're going to calculate the planarity. How are we going to do that? Oh. Is there something that we can use out of the box, or do we have to do this manually? Face planarity. V-ray face, mesh face. Okay, let's look at the mesh face. Structure is quad, is triangle, unset, compared to, is valid, is repair, set, equality. How are we going to do this? Rhino C# face planarity. Is there anything that we planar surface? No. How to generate a hexagonal non-planar mesh with a single face? Is planar? VREP faces. Polyframe efficient computation for 3D graphics statics. Masood from UPenn. This looks pretty cool. Oh, this looks like a really interesting paper. Okay, I'm gonna read this later. I'm getting triangulate quad mesh, planar quad meshes. Triangulate a quad mesh. Vertex at face, least finish triangle. Yeah. Is quad, new faces, before and after, but that's not what I want. I want a quick way, without having to write it myself, to check if a quad face, if a quad face is not planar and how unplanar it is. Rhino poly surface to mesh. Mesh to poly surface. Okay. I think I'm getting myself into a lot of trouble here. Am I getting myself into trouble here? We could do this manually by just iterating over the faces, looking at the fourth vertex, projecting it to the cross product of the first two. Yeah, but I think that's something that we're not going to do right now in the live stream because, I mean, it's a little too late. So, and I have to go. So, okay, so that was more than I thought. Okay, yeah, that was more than I thought. So, I guess we're not going to record the tutorial today. We will do that next time we meet. We will do that next time we meet. And I apologize if this took us longer. It's just that I'm not used to doing custom rendering with Grasshopper. So it was more, literally it was like an exploratory live stream for me. I am going to prototype this thing probably this weekend. It should be pretty quick. So I guess next time we meet, we will record this video with these examples and then move on the list. Okay. So that's going to be it for today. All right, that's going to be it for today. Any questions, comments, anything you want to touch upon? Real quick social. Anything? Did you find this useful? Was it cool to see me exploring this stuff? Was it just boring? Would you rather just see the thing done? How do you feel about it? I'm open to questions, comments, suggestions, screaming, if that's what you want. You can write all caps to yell at me right now. All right. Okay. All right. Okay. Well, if there's no more comments or if you think it was cool. I hope you have an amazing day too. Thank you, Nicholas, and I will see you on the next one. Bye bye. Thank you.